it has been dubbed the most mysterious star in the galaxy. The star, more than 1,200 light-years away in the constellation Cygnus the Swan, flickers and dims in a way never seen before. The starlight dips in an irregular pattern, suggesting that something is intermittently blocking the star. This bizarre behavior, first reported in autumn 2015 and not seen in any other star, has scientists baffled. Researchers have proposed a myriad of explanations, including black holes, comet swarms, and interstellar clouds. But a conclusive answer remains elusive. And one hypothesis in particular has raised eyebrows: aliens. Yes, aliens. Perhaps, researchers have posited, an advanced alien civilization has constructed a vast structure encircling their star, maybe an enormous power plant that harnesses the star's energy. When parts of the structure pass in front of the star, it creates dips in the starlight. If true, such an alien megastructure would be the biggest discovery in history. And if you were to believe some of the headlines over the past year, you might think proof was imminent. Of course, much was overhyped, and to be clear, no scientists are claiming that this star, named KIC 846-2852, is evidence of ET. Still, scientists cannot discount the alien hypothesis just yet. Until astronomers collect enough data to prove otherwise, an alien megastructure remains a speculative and tantalizing, albeit unlikely, possibility. Even people who were maybe annoyed at the alien angle have to admit that it's a really good mystery, says Jason Wright, an astronomer at Penn State University in the U.S. This is not the first time astronomers have evoked aliens to explain something weird in space. When astronomer Jocelyn Bell Burnell discovered rapid pulses of radio waves in 1968, she labeled the mysterious signals LGM, for Little Green Man, to indicate that they might be extraterrestrial messages. But she was being tongue-in-cheek, and astronomers quickly realized these signals were coming from rapidly spinning neutron stars, which they would eventually call pulsars. But unlike many of the previous false alarms, which usually assumed an alien communication beacon, the megastructure hypothesis is one with relatively specific predictions. In his 1937 science fiction novel Star Maker, Olaf Stapledon speculated that an advanced civilization, thirsty for energy, would eventually need to extract power from its star. To do so, it would have to build a structure that encloses its star. Inspired by this idea, the physicist Freeman Dyson proposed in 1960 that the search for intelligent life should target these structures, which are now often referred to as Dyson spheres. As recently as 2005, an astronomer named Luke Arnold suggested that such a structure could also be used to create a flickering signal that announces the existence of an alien civilization, like an interstellar Morse code. To detect the subtle dips in starlight caused by one of these structures, you would need a sensitive telescope trained on stars for a long time. As it turns out, this telescope already exists. The Kepler Space Telescope, launched in 2009, was designed to find planets around other stars. For 4 years, Kepler stared at one patch of sky roughly the size of your extended fist, watching for dips in starlight caused by planets passing in front of their stars. Kepler has been a triumph, discovering more than 2,300 of the 3,400 confirmed planets known so far. But Wright realized the telescope could also detect alien megastructures, if they exist. He was pondering that possibility when he learned about a particularly puzzling star in the Kepler database, KIC 846-2852. For years, astronomer Tabitha Boyajian, now at Louisiana State University, and her colleagues had been grappling with this star. In fact, it is now called Boyajian's star, or sometimes Tabby's star. A group of citizen scientists, through a program called Planet Hunters, discovered this star's peculiar, irregular dips and brought it to her attention. In one of the dips, the star's brightness plunged by 22%, a huge drop that suggests something expansive was blocking it. For example, the planet Jupiter is the largest in our solar system, but such a planet would cause only a 0.5% drop in brightness. No one could figure out what was going on. For a scientist, that's exciting because it's new, Boyajian says. But it's also frustrating. When her team published their data in 2015, they called the star the Where's the Flux star, or, since astronomers love clever acronyms, the WTF star. They tentatively suggested a swarm of comets might be creating the DIPs. But when Boyajian showed Wright the data, he realized that the DIPs were consistent with an alien megastructure. That is, if an alien megastructure exists, it might make DIPs similar to those seen from Boyajian's star. The DIPs themselves are not that weird. Kepler and other telescopes have seen many stars with sudden and brief drops in brightness. For instance, young stars are often surrounded by a disk of gas and dust. These disks are the raw material from which planets can form, and they obstruct light. But the strange thing about Boyajian's star is that it is a run-of-the-mill, middle-aged star. It also does not emit any infrared radiation. Astronomers expect anything that could block starlight, such as a disk of dust, would also be close to the star, so it would heat up and glow in infrared. But astronomers have not detected any infrared radiation, suggesting there is no disk at all. Then in January 2016, the star got even weirder. Bradley Schaefer, an astronomer at Louisiana State University, found that in addition to the short-term DIPs, the star appeared to have dimmed 15% over the last century. Schaefer had gone through the archives, looking at images of the star taken on photographic plates dating back to 1890. But because the analysis relies on rare expertise in photographic plates, not all astronomers were convinced. More convincing evidence would come in a few months. Benjamin Montet at the University of Chicago and Josh Simon at the Carnegie Institution for Science looked through Kepler's 4-year trove of data, and found that Boyajian's star dimmed by 3% over 4 years. That does not confirm Schaefer's longer-term analysis, but the results are consistent. This seems to lend a lot of support to what Schaefer claims, the fact that we observe dimming similar in nature to what he observes, Montet says. This slow dimming, punctuated with DIPs, makes the star even more difficult to explain. For example, it is hard to see how a swarm of comets, Boyajian's initial suggestion, could account for long-term dimming. The megastructure hypothesis can potentially explain the dimming. Wright offers one possible scenario: if the structures consist of a multitude of objects such as solar panels, which orbit the star at different distances and speeds, they could conceivably dim the star over years or decades, like a slow-moving flock of starlings obscuring the sky. But recently, taking into account this gradual dimming, a new proposal has gained favor among some astronomers. Maybe the star is devouring a planet. In this scenario, a planet was once orbiting Boyajian's star. Another, nearby star exerted a gravitational tug on the planet, altering its orbit enough to send it plunging into Boyajian's star. As the planet approached the star, its outer layers, or, perhaps, its moons, got stripped away, leaving behind a trail of debris that is still in orbit around Boyajian's star. This debris could be causing the DIPs. When the planet finally crashed into the star, temperatures rose and the star brightened. After a while, as the energy dissipated, the star began to fade back to its normal brightness. It is this gradual dimming that Montet and Simon, and perhaps Schaefer, now detect. The planet crashing idea is promising because it explains both the long-term dimming and the short-term DIPs. Our scenario is really one of the first ones to connect them into a common cause, says Brian Metzger, an astrophysicist at Columbia University who helped conceive the new hypothesis. But it also suggests these planetary collisions are more common than anyone would have thought. Boyajian's star may be one of a kind among Kepler's nearly 200,000 stars. But our galaxy has about 100 billion stars, so if you extrapolate the numbers, there should be millions of stars like Boyajian's, and at least thousands of planetary collisions should happen every year. Because astronomers had only noticed the DIPs after the fact, no one has ever seen them happening in real time. To catch these DIPs in action, Boyajian is leading an effort to use the Las Cumbres Observatory, a global network of telescopes, to monitor the star. She is also enlisting the help of amateur astronomers through the Association of American Variable Star Observers. Once they detect a dip, astronomers can point other telescopes to study the star in greater detail. For example, the Spitzer Space Telescope could identify bursts of infrared light, a potentially crucial clue. According to the planet colliding hypothesis, debris blocks light when it passes in front of the star during its long, elliptical orbit. The debris would also heat up and radiate in the infrared. But the radiation is temporary, stopping once the debris orbit takes it further from the star. Capturing this infrared flash would lend support to a planet collision. Astronomers are also looking forward to the results from the European Gaia mission, which is measuring the distances to 1 billion of the nearest stars. If Gaia can pinpoint the precise distance to Boyajian's star, astronomers will be able to understand its true brightness. By comparing that to the star's observed brightness, researchers can determine whether the gradual dimming is simply the star returning to normal following a planetary crash. However, that data may not be available until at least 2019. Future observations will answer more questions. For example, another plausible theory is that a big cloud of dust and gas is drifting by, somewhere between Earth and Boyajian's star. Denser clumps may cause the dips, and a transition from a thinner to thicker part of the cloud causes the long-term dimming. But what about aliens? In principle, they are still on the table. Setting aside the sensationalized media coverage, the alien megastructure hypothesis is still arguably a scientific one, and a valuable speculative exercise. At the very least, Wright says, it gives alien hunting astronomers a target at which to point their radio telescopes, in their search for extraterrestrial signals. Initial observations using the Search for Extraterrestrial Intelligence, SETI, Institute's Allen Telescope Array in California have turned up empty. However, in January 2017, Wright, Boyajian and Andrew Simeon of the University of California, Berkeley, used the Green Bank telescope in the U.S. for a more thorough search. They are now analyzing the data. For others, such as Metzger, who proposed the planetary collision hypothesis, the prospect of aliens brought their attention, and maybe some derision, to a star they might otherwise have ignored. I was a little bit distraught that the alien megastructure was considered a plausible explanation, he says. If we could find some other mechanism, that's vastly preferable. Solving this mystery will probably take a few more years. Most scientists, including Wright, would likely agree that alien megastructures are a last resort explanation. But even if the answer is not alien, scientists say, it will still reveal unexpected and important insights into the universe, whether it is about planetary collisions, globs of gas in the interstellar medium, or something else altogether. The fact that we've gone this long and can't come up with a satisfactory explanation is interesting, says Eric Momajek, an astronomer at NASA's Jet Propulsion Laboratory. We're going to learn from it, no matter what it is. Solving this mystery will probably take a few more years, Momajek says. The answer could turn out to be singular and unique, or it could be something more fundamental. In the near future, more powerful instruments will monitor the sky with unprecedented sensitivity, potentially discovering more objects like it. In the past, the discovery of one bizarre object has often heralded a new class of phenomena. So, if history is any indication, Boyajian's star may be just the beginning.